Material entities and process profiles. So these are two parts of the BFO upper level that I didn't really talk about. I didn't say anything about the occurrent side of BFO in previous discussions of the Buffo architecture. The occurrent side means processes and temporal regions, and spatiotemporal regions. So that the occurrent side is where things occur. The continuant side is where things exist, continue to exist. Now, material entities are continuants. Material entities are things which have molecules as parts, very roughly. BFO claims to be able to deal with any kind of scientific phenomenon by creating the basis for domain-level ontologies for those phenomena. But we don't make any claims regarding entities at the submolecular level of granularity, such as, for instance, entities dealt with by quantum physics. Although I will have something to say about quantum physics later in this lecture if we get that far. So there are two kinds of independent continuant in BFO. Independent continuant means those things which can be the bearers of attributes or the participants in processes. On the one hand, there are material entities, which are, as I just said, those entities which have molecules as parts. And then on the other hand, there are immaterial entities. And immaterial entities are, first of all, sites. So this room, the interior of my mouth. Continuant Fiat boundaries, such as the boundary of my body, and the boundary of the interior of my mouth, and the boundary of the opening, which is the opening of my mouth when my mouth is open. And then spatial regions. And as I explained a week ago, we distinguish sites from spatial regions. Sites are always three-dimensional. Three-dimensional spatial regions are that in which sites, objects, boundaries, sites and objects exist. Boundaries exist in 2, 1, or 0-dimensional spatial regions. And both sites and objects can, in principle, move from one spatial region to another. So now we need to deal with material entities, which are the most important kinds of entities because we are material entities. So more particularly, we are objects. And we're going to have to define object, and we're going to have to distinguish objects from the other kinds of material entities dealt with by BFO, namely Fiat object parts and object aggregates. Now, there may be material entities not dealt with by BFO. An example would be let me think about this. The object, the whole with a W, which is made of me and Neil's upper torso. So Neil's upper torso is a Fiat object part. The boundary between his upper and his lower torso is not a physical discontinuity, or does not go with any physical discontinuity, in the way that the boundary around his exterior goes with a physical discontinuity. So the sum of me, I'm an object, and his torso, which is a Fiat object part, is neither an object, nor is it a Fiat object part, nor is it an object aggregate, as we will see in a minute, and so it doesn't fit into BFO. Now that's fine. That's not a problem, because we can very easily define such cases if we ever need them. And it's very rare that scientists have to deal with combinations of people and Neil's upper torso, or any upper torso related data. And so there is no need to have a term in BFO for those kinds of entities. But if we needed one, we could add one, and we already know exactly how to do that, and so it's not an issue. BFO will change if it needs to change in order to accommodate new kinds of scientific data. All right, so how do we understand objects? Well, in intuitive terms, objects are the natural units in the realm of material entities. So Neil's upper torso is not a natural unit. Neil is a natural unit. I am a natural unit. Cells and molecules are natural units. And this paper plate is a natural unit. And this table is a natural unit. And this chair is a natural unit. All of those things are objects. And now to capture formally what it means to be an object is going to be quite tricky, because there are so many different kinds of natural units, and we want to do justice to the natural units in a way which will cover the main candidates, leaving open again the possibility that in the future we may find that there are other candidate families of natural units which need to be added to this list. So the first kind are biological entities, which are natural units, and Aristotle thought that all substances, Aristotle uses the word substance, or the Greek word substance, to mean what we are calling object. But he thought that all objects are organisms, and all organisms are objects. And we think that there are other kinds of objects in addition to organisms, such as laptops, which Aristotle just didn't really do justice to. Another kind of object are portions of solid matter, not portions of solid matter of any sort, but those portions of matter which have their own boundary, which separates them from other portions of solid matter or from other material entities by being a physical discontinuity. So a mountain may be an object, but the mountain that you see above the horizon is not an object, because there is something underneath it which it is physically continuous with, which is the base of the mountain, which is underground. In fact, if I understand mountain geomorphology correctly, mountains are like icebergs. 2/3 of the mountain is actually under the sea level, or the relevant level of ground. So, and I don't know whether mountains as a whole are coherently described as portions of matter which satisfy this rule that they have a physical discontinuous boundary, separating them from the rest of reality. But certainly small pieces of granite, lumps of rock, pebbles, stones, coins, pieces of leather that you find in the street all the time. All of these are objects. Okay, because they are separated from the rest of reality by a complete physical discontinuity. Now, that doesn't mean that they have a boundary around all parts of themselves. Very many objects and all organisms have pores or orifices which allow the entry of things like food and oxygen. But they still have a physical discontinuity which separates them from the rest of reality. It's just that this physical discontinuity is contains gaps which are small in size relative to the entirety of the boundary which separates them. If these gaps become too large, for instance, if we cleave an amoeba into two parts, then we destroy the object. The object's livelihood or ability to survive is damaged. That's what happens if we cleave Neil into his, what used to be his torso and now his legs, but which are now three objects. So we turn Fiat object parts into objects through cleaving, which is normally deadly it's deadly for organisms, and it's the equivalent of deadly for non-organism objects. And then there are engineered artifacts such as laptops and so forth. And cleavage works here too, and that's normally the equivalent of deadly for artifacts. Now, there are all kinds of problems with this trichotomy. First of all, suppose you have a screwdriver which it contains two parts, the handle and the blade. I don't know what's it called. The other part.
The head?
The head. Well, the head would be the handle, wouldn't it?
I think the head.
Okay, so he thinks the head. So we'll say the handle and the head. Now let's suppose that the handle and the head are held together by a screw arrangement so that you can take them apart very easily. Here, cleavage would not be deadly for the survival of the object. So here we have a problem. The classical problem in philosophy is the problem of the watch. You have a watch, it's broken, you take it to the watch repair shop, and it's taken apart, cleaned and mended, and then put back together again, and the repair person gives you your watch back. Now, is it the same watch? He says yes, he's very confident. I think he's right. But what happens to the watch during the period when it's taken apart? It's certainly, if it's the same watch that you get back, and the watch was not subject to the equivalent of some deadly cleavage in the way that amoeba would be if you cleaved it in half. You can't put the amoeba back into the tube of toothpaste, as it were. You can put the watch back together. So this is a problem. The attractive idea is to say that objects only have one beginning to their existence. And if you destroy them, then you have to start again from scratch. But the fact that we can take watches apart and then put them back together again suggests that this attractive axiom is not quite right. There are many more similar kinds of cases. So let's suppose that I'm an artist and I do installations. And I just created my first installation, which I'm sure you'll all be impressed by, which is a bottle with a screw top, which I especially installed by screwing it on the bottle. So this is it. I call it bottle number 1. Now, by mistake, someone who is very thirsty unscrews the screw top. But fortunately, we catch him before he drinks any of the water. And we very carefully put the screw top back on, but we don't do it in exactly the same way. Now, is it the same work of art as before? Or was the work of art just destroyed? Now, is it the same object as before? If it's the same object, then presumably it's the same work of art. Now, there are, everyone is looking very puzzled, but believe me, there are philosophers who work very hard to try and find good answers to this question. I have to be very careful now, I don't want to insult my colleagues. There are some philosophers who think that this question proves that works of art do not exist. Oh, let me be more careful. The works of art of this kind, roughly object works of art, do not exist. Because we have no criteria of identity. Is this the same work of art, or is it a different work of art? Who knows? If we don't have a criterion of identity, they say, then there can't be an entity there, because Quine, who is an important philosopher, has the slogan, no entity without identity, by which he means no entity can be allowed into our ontology unless we have a criterion of when we have the same entity again. For works of art, not only for this bottle, we don't really have good criteria of identity. So even a sculpture, if a sculpture in a park somewhere gets affected by wind and vandalism and changes its molecular structure, is it the same work of art after 100 years of wind erosion? Proponents of this view would say we have no way of knowing, and therefore there are no such things as works of art. So, we are going to take a more commonsensical view But we're also not going to be able to give good criteria of identity for works of art and for many other kinds of objects. Is his laptop the same if we take out the hard drive and replace it with a new hard drive? There are deep philosophical questions associated with issues of this sort. We're not going to worry too much about them. We're just going to accept these as being our categories of objects so far, and realize that we're going to find it hard to define criteria of identity. So we're not going to accept Quine's principle that there is no entity without identity. And one reason for not doing that is that even organisms, which are usually, as in the case of Aristotle, the prime candidate for objecthood, even organisms don't have good criteria of identity. So if we replace Neil's heart with somebody else's heart, is Neil still the same Neil? If we replace his brain, if we replace just a few molecules in his brain, so that his personality has changed quite radically. Anyway. So, and then there are other problem cases. So is this one object or two? So we have two cells, but they are tightly joined by all kinds of biological mechanisms upon which life depends. Now, a practical solution to this kind of problem is to and this is the practical solution in all ontological problems of this sort. If you're not sure whether this is an object or an object aggregate, then you use the next level term in the ontology when you're describing your data. In this case, the next level term is material entity. And very many people working in cell biology just don't use the word object. Even though I said that cells are good examples of objects, because they are concerned by this kind of case, they instead prefer to treat cells as being material entities. And they're still right. If cells are objects, then a fortiori cells are material entities. Another analogous problem which arises is Siamese twins, or conjoined twins. So there are cases of conjoined twins. I think they are objects, one object, in fact, because they have one single physical discontinuous boundary which separates them from the rest of reality. And if we can separate the twins, then we have two objects. So the fact that the twins are conjoined means that they are one object. That's what conjoined means. Conjoined is another word for continuous, or continuously connected. And so if we can cleave them, in this case, the cleavage would be not deadly, or if the operation is successful. And the operation is going to be successful the smaller the connection is between the two halves of the conjoined twin. And remember I said that objects can have gaps or holes with an H in their boundaries. For instance, orifices like the mouth and the ear. Now the Siamese twin case shows that objects can also have small connections relative to the entirety of the boundary between themselves and other objects. Providing those small connections are small enough, a cleavage could still take place, which would create two separate objects. Two individuals might be there beforehand. Two human person entities, even though there is only one object in the technical BFO sense of object. All right, any questions on object?
Are the typhoon or tornado are objects?
So, this is a very good question, which is at a higher level, and I will deal with it now because it is appropriate to deal with it now. So, I've already said at various points that there are some philosophers called process philosophers. Heraclitus was one example of a process philosopher who believed that everything is just a process. There are no objects. There are no continuums. And typhoons and so on are examples that they very often like to list. Basically, they see the world, or many of them anyway, see the world in terms of two kinds of processes. There are fast-moving processes, such as my waving my arm now, or the typhoon doing whatever it is that typhoons do, typhoon needs to do. And then there are slow-moving objects, such as slow-moving processes, slowly occurring processes, such as me. So the me process, the smithing process. The smithing process moves very slowly compared to the typhoon. Now, I think that's a bad view. I think that there are continuants which continue because they preserve their identity, however quickly they move. So if I was moving at the speed of light now, I would still be a continuant. And the fast-moving, slow-moving is just a different dimension, dimension to evaluate it. So I believe that there is a dichotomy between continuance and occurrence, and that is basically the source of all good metaphysics. And if you deny that dichotomy, then you are creating traps for yourself. But now I am open to a challenge. How do I deal with typhoons? Because on the one hand, a typhoon seems to be able to move across the landscape, but on the other hand, a typhoon seems to be full of whizzing activity. It doesn't seem like a continuum. Another example would be a forest fire. Is a forest fire a continuant or an occurrent? So on the one hand, the forest fire seems to spread through the forest, but on the other hand, it seems to be full of flaming processes.
But I'm just wondering, like we sometimes name the typhoon as such as the Katrina,
Yeah.
things like that,
Yeah.
which is the dependent continuant of.
So I believe that when we name things, that's a very good indication that we're dealing with continuance. So if we name typhoons or hurricanes Brenda, then that, to me, is a very good argument for saying that we're dealing with continuance. The reason we name things is so that we can refer to them at different times in their existence. And Brenda today is very weak, but tomorrow she'll be very strong and threatening Miami. Now, how can I believe that a hurricane, let's say, is a continuant? Well, I prefer to deal with the example of forest fire, just because it's easier to tell the story. And if I can deal with forest fire, I can deal with hurricanes and typhoons. So a forest fire, and I'm going to deal with forest fires by using the analogy of a pack of monkeys. So each flame in the forest fire is like a little monkey. And as the monkeys run or move through the jungle, attaching to successive trees like flames do, they're also giving birth to new monkeys at the front and watching old monkeys die at the back. So that's the idea. Pack of rapidly procreating monkeys moving through the forest. That's what a forest fire is, but the monkeys are flames. That means that a pack of monkeys is a continuum. A pack of monkeys is a continuum, like just as a pack of cells, which is called you, is a continuum. And therefore, a forest fire is a continuum. It's a pack of flames. Now, but so you are a continuum. You are gaining molecules, losing molecules as you move through the forest of life. So many continuants are like forest fire. In other words, they move by gaining new parts. They move, and insofar as they move, they gain new parts as they move forward, and they lose old parts as they shed parts they no longer need. Yes?
Isn't the flames of the tree a disposition of the tree?
So there are dispositions of trees, some strong, some less strong, to catch fire. The realization of that disposition is a fire burning process. So that burning of the tree is the realization of the disposition of the tree to catch fire. Part of the burning process is the creation of flames, but the flames are continuous. They're like little babies, in an extended sense of the word light.
But the disposition is to release gases when it's heated up to a certain degree.
So the disposition of the tree to catch fire is going to be
It's contingent, first of all.
it's going to be a function of where the tree is growing. If it's growing in the desert, it's going to be more likely to catch fire than if it's growing in a rainy place, for instance. And maybe its disposition in a very rainy place is going to be 0.
It's just hard to see why this works on a tornado, because there's no object that...
The tornado is the object. It's a pack of monkeys. It's a big object with lots of moving parts. The molecule is full of molecules. Will that do? The molecules of the monkeys. Is that more helpful? Molecules of
It seems to me that...
water. Isn't that what tornadoes are made of? Molecules of water. They're objects. Put them all together. You spin around, you lose some water, you get more water. Pick up a few cars along the way. Anyway, I can see you're convinced. Yes?
Forest fire is an object or object aggregate because it's
Good. The issue there was whether it's a continuum. In actual fact, it's an object aggregate. It's not an object. So if I said it was an object, that was just a mistake. I meant object aggregate. A pack of monkeys is an object aggregate.
Is a tornado also an object aggregate?
I know very little about weather.
Sure it
but my untutored understanding would say yes.
Yes. Would air turbulence be an object?
Well, now you're using a more technical term. We don't give names to air turbulence. What people mean by air... So I guess that there is a certain minimal level of air turbulence everywhere, or 0 level. So sometimes it's elevated air turbulence. So this is a quality of the atmosphere in a given locale, I would say. So it's a continuum, which like practically all continuance in physical reality depends upon certain processes. It's a continuum, and we measure it. So high air turbulence in this region. All right. So, as I said earlier, that these 3 privileged subtypes of material entity do not exhaust the entire space of material entities. And this very nice paper is criticizing BFO because it thinks that we were claiming to create an exhaustive list of types of material entities, and we are not claiming to create such a list. So these are examples of Fiat objects. There is something behind the cow which I can't imagine is very useful, but let's see what it says. Yeah, so it's not useful because it just repeats what I said a minute ago. All right. Now, we talked earlier on about partitions. Now, sometimes we mean by partitions of reality. So remember Alberti's grid. Partitions of reality which pick out object aggregates by creating partitions with cells, and in each cell in the partition sense, not in the biological sense, in each cell there is exactly one object. So this is the Beatles partition. And the Beatles is an object aggregate. The Beatles are John, Paul, George, and Ringo. But the Beatles is one object aggregate. And it works better if you talk about pop groups with singular names. I can't remember any. They are Rolling Stones. It wouldn't be grammatically, and I don't know the names of the Rolling Stones anyway. So there are many kinds of partitions, and the Fiat object parts. So, for instance, the slice of the planet, which it corresponds to the tropics. I guess that's down here. Would be a Fiat object part of the planet. Now, there are Fiat parts which are not object parts, they are surface parts. So there are two-dimensional Fiat parts. And examples would be geospatial regions, so voting districts in, is that Louisiana? Anyone? That looks like New Orleans to me because it's full of water. So that is Louisiana voting districts. They're all Fiat parts of a surface on the planet. And there are many Fiat object parts, which arise because we partition reality by doing science. So these are Fiat parts of a chromosome. And now we come to object aggregates. So I guess everyone knows about set theory in mathematics. So object aggregates are like sets of objects. So they are unitary entities, like a set, with parts which are like the members of the set. And what that means is that object aggregate doesn't contain any other parts other than just the objects which form the object aggregate. So if John has a handkerchief in his pocket, that is not a part of the object aggregate, which is the Beatles. If John has a banana in his stomach, then that's not a part of the object aggregate, which is the Beatles. Although once he's digested the banana, then that may be there may be some molecules from the banana which are a part of the Beatles. Yes?
It's a set of objects. These objects could be different objects.
You mean of different types?
Yeah.
So we could have a beetle and an apple and a violin. That would be an object aggregate.
Yeah, or for example, in a library, I can have a CD, DVD, or books. So the entire inventory of the library is an object aggregate, insofar as it is confined to objects. So CDs are objects, books are objects, old parchment scrolls are objects. But the library may also have data in databases, and it's not clear that databases are objects. The servers which store the databases are objects. A family, for example.
A which?
A family. Parents and child, for example.
Good. So I think that a family is an object aggregate. However, there are then questions of how you determine the boundary of the family. So do you include dead members, for instance? Is my great-great-grandfather a member of my family? On some uses of the word family, yes. On other uses of the word family, no.
I can include my dog in my family, for example.
In Brazil, maybe.
Sometimes they say, come on with my mom.
So, I guess that there may be a usage of the word family which would include your pets, family pets.
Is it standard to potentially include dead or destroyed objects and object aggregates? Because the Beatles seems like a good
Okay, so now we have yes, that's an interesting question. So in BFO we would only allow existing living still around objects to form a member part. So the member parts are the objects that form the object aggregate. There are other kinds of parts. So that my heart is a part of me, and therefore it's a part of the object aggregate, which is you and me. But my heart is not a member part of the object aggregate, which is you and me. There are only two member parts, you and me. Now, What I said was that the word family is sometimes used to include dead people, but they would not be object aggregates in the BFO sense. They would be, so this is something which I haven't really talked about yet, but sometimes you need to extend BFO or ontologies built to conform with BFO in such a way as to deal with entities which you need to talk about but which are not part of reality. And I think I mentioned some examples already in an earlier class, but this would be another example. So the family in the extended sense means, let's say, all the living members of the family plus 3 generations back, or all the living members of the family plus all the way back to the original Chinese progenitor who is regarded as being the father of the family. So I understand they do things like that in China. That is not really an existing entity. It's certainly not an object aggregate, but it's very useful to have a word for it. And Buffo allows you to define such defined classes, Chinese traditional family or something, because they're useful, and we don't want to make life hard for them. And the same goes for dogs. We don't want to make life hard for dogs. All right, so the Beatles are something like a set. They are a part of material reality, but they are a part of material reality which is picked out by a partition in the special partition picking out way. And what this means is that you mask everything else, but you also mask the internal structure. You just see the members of the aggregate. And there they are. And they are there still. It's just that they're surrounded by other stuff. So you have to focus, you have to mask all the parts of this which are not Beatles. And then you will see the object aggregate. And so on. So we mask the external parts like the water and the internal parts like the cells and the molecules. We just look at the objects, the members. Now, this is a veridical partition, as we say, but we also have non-veridical partitions. These are also veridical partitions. So this is a partition of the kinds of chess pieces. This is a partition of 3 kinds of things that are present in this image. And this is a partition of 1 kind of thing that is not present in this image. But if you're really interested in molecules, you can use the molecule partition to study what is depicted in this image. And all of those are veridical partitions. But there can be non-veridical partitions. For instance, the partition which says there are mammals and there are whales. Oh no, that's wrong. There are fish and there are whales, where the fish partition is a cell within the mammal partition. That would be a non-veridical partition because whales are not fish. All right? They are mammals. And we may come back to non-veridical partitions later on. All right, now, one big difference between BFO object aggregates and BFO sets is that object aggregates can change their members. So the Beatles may have thrown out Ringo, for obvious reasons, and replaced him with a drummer. Actually, I don't mind Ringo at all. I was just an example. But the Beatles would still survive. And the same thing happens with football teams all the time. That they get rid of somebody and replace them. So in set theory, the members of the set define the identity of the set. If set A has different members from set B, then they're different sets. If object aggregate A has different members at time t from what it has at time t prime, it may still be the same object aggregate. Now that means that we need to have additional ways of understanding identity for object aggregates, and that means we bring in the organizational structures which belong to things like pop groups and sports teams and chess clubs and universities and governments and families and so forth. So we allow the same object aggregate to have different members at different times and yet still be the same. And this happens already with tribes, where we do not have any formalized organizational structure, but it happens to a much greater degree when we start dealing with organizations. All right, so this is the library example that Fernanda introduced earlier. This is the object aggregate, which is the inventory of all the... I guess it's a warehouse, not a library, but it might have been a library. And then we have member part of at time t, that's the relation between objects and object aggregates. And we have organizations, which are object aggregates plus specified roles. And now we go back to this, and I don't think we need to talk about this because we talked about this a week ago. Now this is how we deal with roles. So, in fact, I will treat these. These are different roles, or they are to be understood in terms of different roles that a human being plays at different times in her life. Actually, it's John, so I better say his. So John is first an embryo and then a fetus and so on. It's always the same John, the same human being, a continuant, but as John grows, as John develops and grows, he has different roles. And this is how we understand roles. So John is an instance of embryo at t, means John is an instance of human being at t, and there is an embryo role, which is John's embryo role, which inheres in John at t. And role universals are rigid. What that means is that I cannot have your role. So my embryo role was a different thing, a different entity from your embryo role. So roles are tied intrinsically to whatever the bearer is at a given time. Now, there may be some kinds of roles in the realm of social organizations, for instance, president role, where we are tempted to say that the role can indeed migrate. So one person has the president role at this time, and another person has that very same president role at another time. But I think this is to confuse role with office. And the office is defined in terms of the role. And we can go back to that issue later on if people are interested. All right. So this is the partition, and it's very difficult to see because he's half obscured by the fact that the image doesn't go far enough. The cells in Ringo, truly, they still do exist, actually. The object aggregate of all the cells in Ringo is a veridical partition. And the partition of all the molecules in Ringo is a veridical partition. Now, these are two distinct object aggregates. The object aggregate made of all the cells in Ringo is one object aggregate with so and so many trillion members, and the object aggregate of molecules in Ringo is another object aggregate with, I don't know, so and so many bigger trillions of members. They are partitions of the same part of reality, but they are different partitions at different granularities. And BFO is designed to be a common ontology for partitions of reality at different levels of granularity. Now we come to another idea which belongs now to the occurrent part of BFO. So we define the term history like this. So Ringo has lots of processes going on in his molecules, lots of processes going on in his cells, lots of processes going on in his organs, lots of processes going on in his drum playing hands. If we sum all of those processes across the whole of Ringo's life, we get what we call the history. And every material entity has a history. And there is a one-to-one correspondence between material entities and histories. If you have a history, then you can work out which material entity it belongs to. And if you have a material entity, you can work out what is its history. Now, this is useful because it means that if you have a friend who is a believer in a process ontology, and if the friend says, we don't need all these objects, and so we're not going to use BFO, then you can just say, oh, you can just use the histories, and then you get exactly the same collection of entities as if you'd had the objects. Moreover, if, as is the case, there are some pieces of software which can only work if the assumption is made that everything is a process, then you can still use those pieces of software to support work involving BFO, because you just have a one-to-one correspondence between the histories which the software can deal with and the objects which the software can't deal with. And I can explain the reasons for that if anyone is interested. All right. So I said all of that. Histories are additive, so for any two material entities A and B, there is the history of the sum of those material entities. So there is the history of the Beatles, which is the history of John summed with the history of the other Beatles, whose names I forget. All right, now we're moving on to occurrence. So let me just give you the strategy here. Yes?
I want to ask you about the Beatles. Isn't it ambiguous that we refer to Beatles in two different ways? And so in some ways we say that the Beatles were a pretty popular band, and on the other hand we say that the Beatles are a great part of the history of music, and so in some way we refer to the Beatles as something that doesn't exist anymore, and in another way we refer to the music, and so they still exist. We say that the Beatles are my favorite band. We don't say that for like government, like the French.
Okay, so this is another version of the families problem raised by Fernandez. So the Beatles do not exist, but we can refer to the Beatles, and we can even say the Beatles are an object aggregate. But what we really mean is that the Beatles, during the time when they existed, were an object aggregate. Now, the Beatles, as I just said, have a history. And very often when we're talking about the history of world civilization in the 1960s, 70s, 80s, then we will describe the Beatles as an important part of history. And we're then really referring to the history of the Beatles rather than to the Beatles themselves. The Beatles themselves were an important participant in the development of world civilization, or a tiny fraction of world civilization during that period.
Think about this. If I consider in a family a group of people, and one people die, then it's
the same family.
The same family, in a different configuration.
If you like,
Because the object aggregate is the same.
So
with a member less.
Yes, so
alive.
The family survives if one person leaves, but that may not be the case. Let's suppose that you have a family, and there are two parts of the family, because there's one part which, so the oldest grandparenty people are just two people who divorced, plus the father of one of them. Okay, so we have the father of one of them, who is still alive. Then the son divorced, and all the family comes together, even though there was this divorce, because they all want to please the grand old man who still survives. So there are two separate, distinct parts of the family who are still consider themselves part of one family, still are part of one family, because this old man is still there. Then the old man dies. All the hatred comes out, and the family splits. So there is no longer a family, because he died, and there are now two families who hate each other. This is how species evolved biologists. So they don't.
If my family is me and my husband,
Yeah.
and one of us die,
Yeah.
it's the same family, but it's not.
So this is the problem of vagueness, and so if we let's suppose we have a heap of stones here, and we take away one stone, we still have a heap. You agree? Assuming, yeah. So now take away another one, we still have a heap.
Yeah.
Now we take away another one, and we still have a heap. All right. Now we come back in 20 minutes, and there are only 2 stones left on the table. Do we still have a heap? All right. So no one knows the answer to that problem.
I have a question about roles, but do you want to continue on with occurrence?
No, I'm fine to do wrong.
So I have a question about roles. So we have position roles like president, but then when you were talking about deontic entities in the last couple of weeks, you were also throwing out all of these other kinds of roles like obligee and obligor role, authority role, boss role, expert role. Pretty soon we're wearing lots of hats.
Yeah.
Do you have any thoughts or insight about how these roles might be related so that we're not just wearing lots of hats, but maybe they are related to one another? So in virtue of being the president, I also have obligor roles that are somehow part of that president role.
So when you are appointed president, it will give you a long list of your duties. They will give you another long list of the people who are subordinate to you. And each one of those people will be getting a long list of the people who are subordinate to them, and so on. And they will also be getting a long list of their respective duties. So when you become the president, there is brought into place around you a gigantic filigree work of obligations, duties, and authority roles connecting to the duties of the people beneath you. Now that gets you a lot of the organization. I can't use the word organization here. That gets you a lot of the content of the role structure involved in organizations. Now, that role structure goes hand in hand with certain disposition, expertise, skill, and so on, kinds of structures. Do you want me to go on, or are you now happy?
Maybe kind of, because I'm wondering if I'm president, does that automatically mean that I have authority, or does it depend on the documents that describe the presidency, whether or not authority is a portion of the president?
So, I think that this is a question which relates to the philosophy of constitutional originalism to some degree, if we're talking about the President of the United States. So let's not talk about the President of the United States. Let's just talk about the President of an organization. Now, the simplest case is we have an organization which has one goal: to feed hungry people in poor countries. And they appoint the president because they have a very pragmatic approach. They want to achieve this goal. He has certain duties. He has to perform those duties. And he has certain employees who have to perform their duties, and that's it. But that would be a relatively rare case. Typically, you would appoint a president because he already has lots of friends in the helping poor people community, and lots of influence and charisma and money and so forth. So it's typically more complicated. But that's why we need this complicated, humongous net of intersecting roles and dispositions, because the world is complicated.
Yeah, I just worry about designing a system where we have 10 different roles that we're wearing when there's obvious relationships between them. And we could probably do the work with fewer.
So first of all, I never worry.
Okay.
Secondly, there is a lot of bad philosophy which comes about because people think that this particular theory looks very complicated. So wouldn't it be nice if we had a theory in which there are no minds, or there are no organisms, or there are only molecules, or only quantum fields? You can pretend all you like, but Neil's torso is still going to exist.
I won't quibble with you on that one.
And Neil's role as chief quibbler, or chief non-quibbler, will still exist, if he has that role. Even if you say, oh, there are no roles in reality, it's just a way of talking. There are some things which are just a way of talking. For instance, the traditional Chinese family, which contains parts which exist at different times, so it never exists. It's a continuum, but it never exists because it never exists as a whole. But we can talk around that by defining it very carefully. Yes?
Is object only be defined for living things or existing things?
Yes, but we can still use the word object to describe what things used to exist. So Socrates was an object. John Lennon was an object. They are truths which are conformant to the BFO way of understanding.
Let's assume there was a chicken which lived in Buffalo, and it was killed and cooked.
Yes.
And it became a dish of
a dead
buffalo wings.
chicken.
Cooked chicken.
Yes.
So obviously, when it was alive, it was an object.
Good.
But after it was cooked, was it still?
So actually, I do believe in existence after death, even after cooking. So I think the chicken still exists even after it dies. It still exists even after it gets cooked. When it ceases to exist is when you take it apart. Then you have an ex-chicken. Or you don't have. So the chicken is destroyed by dismemberment. This is the cleaving of the amoeba. You destroy the amoeba because you cleave it, and so it can't survive anymore. All its innards leak out. And when you eat a chicken, then you cleave it apart. Now, if you were a really big snake, and you could eat a chicken in one mouthful, which some snakes do, then the chicken might even survive being eaten, but it won't survive being digested. So that's my line on chicken.
and I still have another problem on the Beatles. Like
Yes.
Let's assume that if the Beatles disbanded, maybe John claimed that they disbanded, but Paul said they didn't.
Yeah.
So how do we? So that the Beatles is still an aggregate.
Okay, good. Now this is an important question. So when we are dealing with things like the Beatles or things like China, then we're dealing with social entities. And social entities, and this is something which John Searle emphasized in his books on the constitution of social reality. Social entities depend in part upon the beliefs of people. They depend in part on documents also. That's something which I like to emphasize. But they certainly depend on beliefs. Now let's suppose that the Beatles split. So we'll just take it simple. John and Paul go off and form and reform the Beatles with another drummer and another George. But that Ringo and George go off and form another Beatles with another singer and another John. So now we have two competing Beatles. And it may be that neither of them is ever believed by people to be the Beatles. It may be that one of them, everyone says, oh, George and Ringo wanted to recreate the Beatles too, but look what happened to them. Because everyone knows that the real Beatles are the John Paul Beatles. Or it may be that everyone is comfortable with the idea that there are two the Beatles. There used to be two popes. And it wasn't true that everyone was comfortable with that idea, but enough people believed in the rightful popeness of each pope, that it would be a generally accepted fact among historians that there were, for a period, 2 popes. And it could be a generally accepted fact amongst music historians that there were, for a people, 2 groups, both of which properly deserve to be called the Beatles. Of course, everyone would have names for them. They would be called the real Beatles and the genuine Beatles, the real Beatles and the Ringo Beatles. Now, that's not funny, because things like that happen all the time in politics. So Kashmir is regarded by India as a part of India. It's regarded by Pakistan as a part of Pakistan. And people die because we have those 2 beliefs, both of which are well entrenched in large parts of the population of the world. And there's no ontological way round the fact that there are in the world social entities which are contested, which don't have a single straightforward status. And I tried to convince John Searle that was a problem for his view, and he didn't see it. So I need to try hard.
And if I believe my dog is my son, he could be my family member.
No, it could be that you believe that he is your family member. But I think that sonhood, so it could be that in Brazil you can adopt your dog. If you can adopt your dog as your son, then there would be a real socially entrenched sense in which your dog was your son. But there could never be a real social... I have to be very careful. And it would be true that your dog is your son. That's the important part. There could never be a real socially entrenched belief that was true that your dog was your biological son. Good. I'm glad you said that. Yes.
So just now you present an example. You said 100 stone is a heap, 2 stones or 1 stone is also a heap.
I didn't say that. I said we go on for 20 minutes, and after 20 minutes, Fernanda has a problem. That's all I said. So somewhere between taking away the first stone and taking away the last stone, the heap of stones ceased to be a heap. It ceased to exist. No one knows. No one has a good account of when that happened.
So there's no agreement that how many stones should be a heap. At least how many stones.
I believe that there will never be an agreement about that for 2 reasons. One, you have different kinds of heap constituting environments. So an environment which is full of sticky stone heap structure supporting atmospheric particles may allow smaller heaps than an environment which is very dry. Stones may have different physical properties, so you can have smaller heaps which are still heaps. But that's one side. The other reason why we will never have general agreement, and I was discussing this with him earlier, is this: who the hell cares? So it's not important for any decision how many stones make a heap.
So
just as it's not important for any important decision how many hairs make a non-bald head. So who cares? It's like
so actually what I feel more interested is you use this example to explain the concept of vagueness.
Of
vagueness.
This is we are now talking about vagueness. The philosophy of vagueness is a branch of philosophy which concerns itself with how do we cope with the fact that very many terms, like heap, bald, tall, short, big, even red, are such that we have a penumbra of cases which are vague in the sense that they are not determinately either one thing or the other. So is this a heap or not? It's in the mid-range where no one really knows or cares. So that the branch of philosophy which deals with those kinds of issues is called the philosophy of vagueness. And it's full of very interesting philosophy, which is not necessarily a bad thing.
Okay, so what's the difference between vagueness and fuzziness?
So there is a sub-branch of the philosophy of vagueness, which has spread itself through computer science and geospatial informatics and so forth, which is called fuzzy logic. Now, fuzzy logic says that you can address, I won't say solve, because some of them are quite modest. You can address the problem of vagueness, or the issues of vagueness, by using probability assignments. We have here 1,000 stones piled in a heap-like shape. It's 99.993726% likely that this is a heap. And then we have a 2-stone candidate heap, and it's 0.00004716% likely that this is a heap. And if you assign probabilities to vague assertions in that way, with non-vague assertions getting very high or very low probabilities, and then the ones in the middle getting middle probabilities, then you can do logic with vague assertions. You can make Japanese lifts work more successfully. So that the Japanese lift software is based on fuzzy logic, it's sometimes said. So it's useful. And I have nothing against fuzzy logic, but I have no idea where all those numbers come from. So why is it 0.000473% likely that a 2-stone heap is a heap? Fuzzy logic assumes that they know all those numbers, and I think we probably don't. Yes?
So speaking of dead chickens that still exist, and moving on to dead human bodies.
Yes, they still exist. So there is existence after death, you should be reassured. Even if for a very short period of time.
But I assume that, so there are not people in BFO.
No, BFO is a formal ontology, so it only deals with those categories which apply to all domains. So the person would be part of a biology ontology or of a social ontology. That's not...
A dead person?
A dead person... so we have the word corpse, and it's used in medicine, and I don't have any problems with corpses. Corpses are people who are dead. Until they begin to be dismembered, and then the corpse ceases to exist, and the person ceases to exist.
You say the corpses are people after that.
Yes, a person.
A person, yeah.
All right.
Yep.
So when I take a lighter and lit it, is the flame a part of the lighter?
I'm trying to think of another question like that where the answer is more obvious.
A match.
I think
The bullet coming out of a gun, water coming out of a water gun.
So let's do the bullet and the gun, because that will give us something to talk about. So when the bullet is inside the gun, it is not part of the gun. It's waiting there to be to exit from the gun, to be dispatched from the gun, and you can replace it. So artifacts generally can have parts, and they can have consumables. So the toner in your printer is not a part of the printer, it's a consumable which you replace regularly. Now similarly, the oil in your lighter, I'm getting to lighters now, the oil in your lighter is a consumable, it's not a part of the lighter. Now if you set the oil on fire, then you have a piece of burning oil, plus a bit of atmosphere, oxygen, which is a fortiori not a part of the lighter, because the oil never was part of the lighter anyway.
And you would say the same hole for a match.
Actually, no, it's not so clear there, because the match contains the phosphorus and so on as a part. So when you strike a match, you create a burning match. And I think the flame might reasonably be said to be a part of the burning match.
So when you take a large match, for example, a pine tree, and you lit it on fire,
Yes.
this should be the same logic, right? When you have hundreds large matchsticks, you have...
Yeah, let's stick with the tree first. So let's suppose that we consider your brain. So your brain is now exercising itself. It's firing up. It's like flames in your brain. Now, the firing up of your brain gives rise to speech and so forth, and gestures. Now, the speech and gestures are processes, so they're not parts. So processes are never parts of object, because occurrence are never parts of continuance. So there's a complete wall separating occurrence from continuance, which goes down all the way. So the things which happen in your brain are not parts of your brain, but the parts of your brain which become excited are parts of your brain, trivially. Now, how are we going to treat the tree which has just burst into flames? Are we going to treat it as being an excited... So the excited parts of the tree, which means that there are parts of the tree which are aflame, which are giving off various processes or effervescences, flames flaming, or are we going to treat the flames as being... Well, anyway, so let's think about the tree. Now, the tree is like your brain. It has certain parts which are excited. They are still parts of the tree. Now they're excited by the fact that they are aflame. So the very same parts of the tree are still parts of the tree. It's just that now they are aflame. That is my answer to your question. So take it or leave it. All right, he's taking it. So now let's just summarize what we've been doing so far. I've used the term partition many times. And partitions at different levels of granularity: molecules, cells, people, organizations, countries, planets. And within the world of objects, there are many such partitions which are easy to create and which are the basis of science. So molecular, cellular, organism partitions are used all the time in many different scientific disciplines, because the world of continuance divides cleanly into natural units at different levels of granularity. And as you move up to bigger and bigger things, you encompass more and more of the smaller things as parts of the bigger and bigger things, including organizations like the Beatles and the Miami Dolphins. Is that it? Did I get that one right? In the world of currents, it's much harder, because we don't have quite so many natural units. We have a few natural units in the realm of organizations. A football game, for instance, or a Beatles concert. That's a natural unit in the realm of occurrence. But mostly, the realm of occurrence is much messier than the realm of continuance from the point of view of applying partitions. So this is a familiar problem in the science of recognition of sounds. So it's a cocktail party. There are people dancing. there are people speaking, there are feet knocking and glasses clinking and so on. And what that means is that there is a gigantic mass of waves, vibrations, throughout the whole. Now, all the waves interfere with each other. And if you want to do a mathematical theory of sound recognition, then you're faced with a really difficult problem of how it is that human beings can recognize the sounds of glasses clinking, did I say thinking? Glasses clinking and feet gliding and garments rustling. How do we manage to do that, given that we're listening to one single integrated wave bombarding our eardrum? Now, we can do it. We can recognize streams within complex, occurrent phenomena. So this is what it looks like when you do a study of the waves in question. So with the ears here are able to separate out separate streams within what is in fact an integrated set of sound patterns. So, and those streams exist both in our mind and in the world. So there are feet gliding, there are glasses clinking. It's just that the vehicle which goes from reality, the clinking glass clinking and the gliding and the rustling, to the recognition processes in somebody's mind, the vehicle between them is a massively integrated collection of waves. So there are auditory streams, even though the realm of auditory phenomena is mediated or vehiculated by complex wave patterns. And so people who work on auditory phenomena, they try to understand what makes an auditory stream. And we have these auditory streams in music. When we hear a concert performance, we can recognize, if we focus, the violin stream or the flute stream from all the other streams. And we do this by appealing to two kinds of signal. So first of all, the violins are all sitting next to each other, and they're playing in the same time. And they tend to be playing in melodic forms which are closely together in space. So the violins will play for a while and then they'll shut down, and then the flutes will play, shut down, but then they'll both play together with other instruments. But there's still a certain temporal proximity of violin sound which we can use in order to track the violin stream. But then we can also use the fact that violins sound alike, and we can use the fact that the intentions of the composer were in part to make us hear the violins as expressing certain common ideas. So Bozzi was one of the early founders of this way of approaching Helmholtz's cocktail party problem. Now, so what we are going to try to understand is streamiform portions or structures in reality. So these occur not only in auditory perception, but they occur also in many other interesting spheres. So our thinking is a streamiform structure, and it too is mediated by waves in the brain. So the fact that we are able to think and be conscious, so to think consciously, is a fact which represents a solution to a similar kind of problem, a similar kind of mathematical problem, actually, which Helmholtz was pointing to in identifying the cocktail party problem. We are able to recognize the streamiform structures in reality, which are called thinking processes, just as we're able to recognize feet gliding processes and glass clinking processes in the external world. And then language, speech is a special case of auditory recognition. But what we recognize when we recognize the speech of someone else is exactly another kind of streamiform structure of reality. And we can recognize the streamiform structure of reality as having not merely a sound quality, but also a meaning quality. So we can recognize the meanings of the sounds which people address to us when we're speaking. And then there are various other streamiform structures in war and chess and football and so on. So basically, nearly everything which is interesting is a streamiform structure. And this lecture is a streamiform structure. All right, and Napoleon's march to Moscow. So it starts here, he has a very big army, and he gets to somewhere near Moscow, I guess, and then he goes back. And by the end, he has a much smaller army. These people, I guess, turn back more quickly. So the history of mankind is a history whose focus is precisely streamiform structures of reality. Now, the streamiform structures in reality are occurrence. They belong to the BFO occurrence side. I want to call these things process profiles. And I wrote a paper propounding some ideas about process profiles as part of an attempt to persuade my BFO colleagues to allow process profile to be added to BFO as a new term, side by side with history. And they convinced me that I should not do it. And there were reasons. I was right in some respects, they were right in other respects, and we agreed to disagree. But still, the idea of process profiles is an idea I strongly believe in, and I think it's interesting to see how it works in accounting for the kinds of phenomena which I've been talking about just now. Now, I'm going to give you a very brief guide to the reasons why I thought we needed process profiles, why I still think we need process profiles. But we are, I'll summarize them now. It may be that we'll go into this in more detail later. So we have in BFO objects, attributes, and processes. Attributes are things like color, temperature, and so forth, strength, turbulence. And processes are things like singing and dancing and running. Now, lots of people say, well, we need a fourth term in BFO, which would be attributes of processes, so that we can say that this running is a 4 mile per hour running, so it has the attribute of being 4 miles per hour. And that singing is a very high-pitched singing, so it has the attribute of being high-pitched. And that clinking is a very plasticky sort of clinking, so it has the attribute of a plasticky clinking. Anyway, you get the idea. So there should be 4 basic categories in BFO: objects, qualities, processes, and process quality. I argue that we can't have process quality. And the reason why we can't have process qualities is because they are not extra entities. If you have a running, which is a 4 mile per hour running, and the 4 miles per hour is not an extra quality, which it comes in addition to the running, so that running might have been a 5 mile per hour running, or a 7 mile per hour running. If it was a 7 mile per hour running, it would have been a different process. Now, if Neil had been 2 degrees warmer today, it would still be Neil. So his quality is an extra piece of information about Neil, which can change while Neil remains Neil. But no process can change from a 4 mile per hour process to a 7 mile per hour process and remain the same process. It becomes a different process. So qualities are not the appropriate way of understanding what we say when we say things like this process is a 4 mile per hour process. What we mean is that this process is this process here, call it run number 3. Run number 3 is an instance of the type 4 mile per hour process, which is in turn an instance of the type process. So, did I say instance twice? I'll start with again. This run number 003, is an instance of the type 4 miles per hour process, which is a subtype of the type process. So the proper way to deal with what we want to say about processes, which sounds like attributing speed or excitement or turbulence or whatever it might be to a process, is not to use quality talk, it's to use subtype and supertype talk. Now, I'm sure that that's right. It brings all kinds of consequences, but I'm sure that it's right. And the reason, I can give the reason best by an analogy. If you have a bowl of 3 oranges here, and you can see 3 oranges, there are not 4 things in this bowl. The 3 oranges plus the 3-ness of the oranges. That's a mistake to say there are 4 things here, as you can see. Similarly, it's a mistake to say that when you have a 4 mile per hour process, and you have 2 things here, a process and its 4 miles per hourness. Because the 4 miles per hourness is already essential to the process. It couldn't be otherwise. Now that's philosophical argumentation. Let's go back now to thinking about process profiles, and you'll see the relevance of what I'm saying as we go down. All right, so what are processes? One view is that processes are what happens within a given region of space and time. So in this region here, this box, there are molecules moving around, and everything which goes on inside this box is the process, which is a sum of molecules moving around processes. And that's all there is. There is just everything which goes on within a certain spatial region. If the spatial region is Europe in the 19th century, then the sum of all the things which went on in Europe in the 19th century is a process. And this view has to face with the following sort of problem. So let's suppose that John is buttering the toast, but someone points out that John is buttering the toast gracefully. Then, according to the view I just described, there is only one thing going on, namely a graceful buttering of the, assuming that both of these are true. There is just a graceful buttering of toast, which can be described either as the buttering of the toast, because that's true, or as a graceful buttering of the toast. Or to take another example, if we say John is pulling the trigger of his revolver and we say John is shooting Mary, we're describing one and the same process, namely all of the things which are going on in a certain spatio-temporal region, which some people describe by talking about John pulling the trigger, and other people describe by saying John is shooting Mary. The same process. Now let's take the simplest possible example of this. We have a spinning top. Now, as it happens, as the top spins, it also gets warmer. Now, the spinning and the getting warmer take place in exactly the same spatio-temporal region. And so, according to the view I just described, which is defended by many serious philosophers, there is only one process here, because a process is defined as everything which goes on in a certain temporal region. And that means that the spinning and the getting warmer are one and the same process. Now this seems counterintuitive. With the graceful buttering, or with the shooting and the pulling the trigger, we could live with the idea that these are just different ways of describing the same process. But when we have a spinning and a getting warmer, it seems counterintuitive to say that we're just using two different words, spinning and getting warmer, to describe the same process. And so we need to reject this view that A process is just what happens within a certain region of space and time. And now, this corresponds to the fact that we can measure two different dimensions of what is going on in the region of space and time occupied by the top during which the region of space and time occupied by the top during which it's spinning. On the one hand, there is the measurement of the increase in temperature, and on the other hand is the measurement of the slightly wobbly spin. And the degree of the distance between the straight line and the curvy line is the degree of wobble. So we could also talk about a wobbling process. Yeah. Now, I think that this is capturing another kind of streamiform structure in reality. So the spinning and the warming up are two different streams which are occupying the same spatiotemporal region and are streams within the moving, behaving of the very same object, namely this top. But they are streams which we can apprehend using different measurement processes. Or even just doing thinking. So if we know enough about the mathematics of spinning tops, we could generate this graph on the basis of mathematical equations. So again, we can apprehend two streamiform structures on the side of the spinning top in our brains, or in our speech, or in graphs. And now I want to say that just as we can apprehend the gliding and the clinking and the rustling in the cocktail party, so we can apprehend the warming up and the spinning as two different processes in the land of the top. Now, you look very perturbed.
Yeah, I'm thinking.
So relax.
Yeah.
So, this may sound trivial, or it may sound as if I'm going down a rabbit hole that is not bringing us to any clear destination. But this issue is an important issue in philosophy. All right. So the account I'm giving says that processes can have different measurable dimensions. We can measure different aspects of processes. Now, what I'm then going to say is that if we can measure different aspects of the processes, then there must be those different aspects of the processes on the side of reality. Otherwise, there would be nothing different to measure. And then my name for those different aspects of processes, different measurable aspects of processes on the side of reality, is process profile. So the process profile, which is the spinning profile, corresponds to the wobbly line on this graph, and the process profile, which is the warming up profile, corresponds to the curved red thick line at the bottom of this graph. So whenever we measure processes in reality, we are in fact concentrating on process profiles along specific measurement dimensions. And processes are always, or let's say generally, much more than just one measurable dimension. So this is the cocktail party problem again. There's always more going on. But we have the ability, in part because we have measuring instruments, in part because we have differential equations and other mathematical tools, in part because we can understand the intentions of the people who create certain processes. We can separate out different process profiles within the cocktail party like world of humming, buzzing processes. All right. Now, when you're a doctor, then when you measure the patient, you're focusing on specific process profiles within that patient's history. For instance, you're measuring the temperature of your patient, and then you have a measurement device which has in accuracy down to 1 decimal place, which means that you're imposing on that process profile, which is Ringo's temperature, because Ringo is your patient, which corresponds to a partition of the measurement dimension we call Celsius measured temperature, or something like that, which has this granularity. And then we can represent the streamiform structure of reality, which is the history of Ringo's temperature changes, or the process profile of Ringo's temperature changes over time by using a graph like this. And the accuracy of this graph depends on 2 factors. I mean 3 factors. One is the accuracy of your device and of your measurement practices, and another is the resolution of your device. So how accurate is, to what degree, so to what decimal is it accurate? And then the third dimension is how often you take measurements. So it could be that between the second and the third measurement, Ringo's temperature does a loop, but the more often you take temperature measurements, the more accurate, the more you will be able to avoid such phenomena. All right, so this is how we measure blood glucose. I don't think I need that. I don't think I need that. And I don't think I need that. So, now I think I probably need this. So, your doctors measure temperature. That's easy for me to deal with. Your temperature changes through time. The course of those changes through time is a process profile, which the doctor can measure at different times. So, assay the value of your temperature at different times and create a graph which represents the process profile. Now, what about heartbeat? So let's suppose that your heart is beating at a constant rate. So what is involved here? Well, we have the heart. We have the process of your heart beating for a sufficiently long period of time to do some appropriate measurements thereof. And then we have the period of time, which is that long period. And then we have the spatiotemporal region, which is occupied by your heart. So you'll be moving around somewhat while the doctor is taking your heartbeat. And then during that period of time, your heart is going to beat a certain number of times, which we call cycles. And the pulse rate is the ratio of this number and this number. So 55 cycles per minute. And the question, and that's the pulse rate, 55 cycles per minute. And the question is, what does that pulse rate correspond to in BFO? So it's not an independent continuum. It's not a process, 55 cycles per minute. It's not an attribute of an independent continuum, seemingly. It seems to be an attribute of a process. And BFO doesn't allow attributes of processes. So how do we deal with it? Well, first of all, one way of dealing with it is that we have an information artifact. Well, actually it's 63 beats per minute. I got that. We have the measurement result. So we measure your heartbeat and write down 63 beats per minute, and then we have created an information artifact. And we talked about information artifacts in an earlier class. And but then we want to know what this information artifact is about. What is it in the world which has this 63 beats per minute-ness? And we could talk about devices. We could say that the device reliably outputs certain kinds of data, and these data are reliable. And this is proved by the fact that if we use them in diagnostic inferences, then we get good results. So if the device says that your temperature is elevated, then that leads to certain actions on the part of the doctor, and those actions tend to give rise to good results, and so the device is treated as being accurate. And this would be a kind of instrumentalist view of this particular kind of data. It's not about anything, but it's instrumentally useful. And I find instrumentalism incoherent, because I believe that if data of a given type is useful, then that must be because the data is about something in reality. So what is it in reality which has this 63 beat per minuteness? And now this is the argument I gave earlier. Processes cannot change. A single process goes from 63 to 65 beats per minute. What that means is not that one process is at one time 63 beats and another time 65 beats per minute. Rather, what it means is that the process has two temporal parts. The first temporal part is a 63 beat per minute process, and the second temporal part is a 65 beat per minute process. So the graph of the process looks like this, and the way to understand this 63 beat per minuteness is not to say that there is one process which has one attribute now and another attribute now. Rather, it is to say that there is one process which has two parts, one of which just is a subtype of the 63 beat per minute type, process type, and the other is a subtype of the 65 beat per minute process type. And this is the three apples in a box thing which I gave you earlier. So now, let me just summarize. To predicate has rate 63 beats per minute of a certain regular heart-beating process is not to assert that the process has a special quality, it's to assert that the process is of a certain type. Process P has rate R is analogous not to rabbit R has weight W, rather it's analogous to rabbit R is an instance of the universal rabbit. And that's why BFO only needs three basic kinds: objects, attributes, processes. Because when we're speaking of processes, predicating certain measurement results of processes, we're binning the processes under corresponding types. Now, the problem now for this approach is that, as we've already seen often enough, processes are very complicated. So, a single running process, we know a lot about it. So it's a 3.12 meters per second motion process. It's a 9.2 calories per minute energy burning process. It's a 30.12 liters per kilometer oxygen utilizing process. It's a cardiovascular exercise process of type 16, and so on. And we're going to have, for every process, like a running, multiple different type hierarchies which that process is an instance of. And that generally is bad practice if you're doing ontology. If you're doing ontology, it's much better if there is only one type for every instance at the lowest level, and then as you move higher there are more and more general types, but there's always one path to the root of the ontology. So Neil is a person, which is Neil instance of person, subtype of mammal, subtype of organism, subtype of object. And there's just one root. Where if we do it like this, Neil subtype of person, and so on up to object, Neil subtype of philosophy student, and all the way up to student.
Full tenured professor.
And that's another story. And then Neil is a hand clasper, all the way up to hand user, to extremity user, to extremity do something with. That's bad ontology practice. You should have one path to the root. So, how do we solve this problem? We solve this problem by saying that a running process P has several process profiles. And for each one of those process profiles, there is only one path to the root. So a cardiovascular exercise process of type 16 is a subtype of a cardiovascular exercise process, which is a subtype of an exercise process, which is a subtype of process, and we get to the root. And a 30.12 liters per kilometer oxygen utilizing process is a subtype of a oxygen utilizing process, which is a subtype of some atmospheric gas utilizing process, which is a subtype of process. So always we have one path to the root because we have multiple instances. And that's what process profiles are. They are a way of cleaning up the hierarchical structure of the massively complicated realm of occurrence. So we're going to focus on thin processes. So there are thick processes like running, and then there are thin processes like burning oxygen. And those thin processes, I call them process profiles. I'm not totally happy with this term. So event patterns, thin processes, streamiform structural parts of processes are all almost equally good candidates, but none of them is overwhelmingly better than process profile. And then we can solve this problem because we are dealing with the heart beating process. This is a 35 per minute heart beating process, which is a subtype of heart beating process, which is a subtype of beating process, which is a subtype of process. And now, how do we define process profile? Well, a first step, and this is why I talked about devices as being reliable earlier on. A process profile is something like that which the output of a correct device would represent. And of course, all the work is being done here by the word correct. But there's a lot of work being done here by wood. So the dinosaurs had hearts which were beating. It seems that they are, when you say dinosaurs' hearts used to beat between 40 and 45 beats per minute, you're not saying, maybe you are saying that if we had been able to go back there, obviously we it's not the case that we could have gone back there. But if we had been able to go back there with heartbeat measurement instruments, then we would have found that they beat it with that particular rate. It's not good practice to define something real in terms of something merely possible, particularly when what is merely possible is in fact impossible. But anyway, this is what we mean, roughly speaking. So this would be a temperature quality process profile. What this means is that it picks out just one way in which Ringo changes, namely the way in which his temperature quality changes. And we could have picked out the way his high quality changes. That's another process profile in Ringo's life. Or the way in which his hunger quality changes. So I'm repeating myself over and over again. I repeat myself when I'm really convinced I'm right, and not everyone agrees. So we say things like, I say things like, what did your temperature do over the last month, Ringo? And Ringo says, well, it went up and down. And there he's targeting a process profile within his own life. So he's performing cognitive profiling. And now, this is a Wiggers diagram. The Wiggers diagram is used by doctors to record information about your heartbeat. And it contains different process profiles, which are measured by different instruments. So this is measured by an electrocardiogram, this is the measures of ventricular volume, this is ventricular pressure, this is aortic pressure, this is atrial pressure, and you can associate each movement in these process profiles with specific events. So here the atrial valve opens, I guess. And here the aortic valve opens, so you get the peak here. And so I could say I rest my case. This is a demonstration of the proof of the correctness of the process profile view of streamiform structures in reality. Now, all of these may be just quality change process profiles, but there are other kinds of process profiles. I think that's also a quality process profile. So, when you listen to polyphonic music, then you are listening to process profiles which are not qualities of one single object, in that case the heart's aortic valve pressure, the heart's atrial valve pressure, and so on. These are qualities of the heart or of the atrium. But here we're dealing with a process profile within a complex process which is produced by different objects, namely violins and violas and cellos and so forth. And in principle also there'll be things like sneezing and coughing going, and paper rustling and feet gliding within the concert hall, but you normally don't focus on the sneezing and the coughing when you're listening to music. Doctors may be different. All right, now let's move more quickly. So Boyle's law is about the process profiles of pressure change, volume change, and temperature change in a gas. And I think that's probably enough. I don't think we want to talk about atherosclerosis. So I have some more about thinking and language, but I think this may be enough. So, any questions? Otherwise, you get thinking in language. No questions? Yes.
So why looked like I was thinking so hard? Processes. One process can be dependent on another process because
Yes.
Because the spinning being one process and the heating up is happening because of the spinning.
So I like to think in those terms. Yes.
Okay, that's why I was trying to separate the process.
So if you are of a more metaphysical bent, then you might say that it's all just one big gigantic process, which is the history of the universe, and everything within that process is equally dependent on everything else. But I'm not of a metaphysical bent. So I do find it quite reasonable to talk about such dependence relations. And there are also causal relations. So one particular process profile may be caused by another process profile. And actually that's what happens in Boyle's law. So you have simultaneous causality between, you cause a rise in temperature, the rise in temperature causes a rise in pressure. I put it simultaneous causality, where the most often considered cases of causality are successive causality, where the movement of this billiard ball causes the movement of that billiard ball. But simultaneous causality is everywhere, because process profiles are everywhere.
So how would you represent that on that one process is coming from another on like the chart?
So we have various relations in BFO. So instance of, we've talked about, is a subtype of, part of, has part. It would be nice if we could add causes or has cause. But we don't have a good definition of cause yet. So we have not, and philosophers generally do not have one single convincing understanding of cause which we can just adopt. Now the closest we come to that is where we can talk about dispositions. So dispositions very often have triggers. So when you have a glass which has a disposition to break if dropped, and you drop it and it breaks, then we can capture in BFO the phenomenon which is the dropping of the glass causing the breaking of the glass by talking about the trigger for the disposition. And many cases of causality are like that. So the billiard ball has a disposition to move when knocked. The first billiard ball knocks the second billiard ball, so the second billiard ball moves, and that's because the disposition of the second ball was triggered by the movement of the first ball. Or the realization of the second disposition was triggered by the movement of the first ball, which was in turn triggered as the realization of the disposition of the first ball to move when knocked, because the first ball was knocked by a cue. Yep.
You've provided a reduction of potential qualities of processes to processes. This is good. But what about, why not use a similar reasoning for qualities continuous?
A, because I don't like reduction.
Sure.
B, because I think that there are very important features of the hierarchies of quality, which we will lose if we give up qualities in terms of added hierarchies for objects. If you do it right, you would probably end up with something of exactly the same complexity. Mm-hmm. And so there's not really going to be any benefit in terms of economy. So the ontology of process profiles is very rich. Mm-hmm. The benefit is that you don't need an ontology of process attributes. But in order to have that benefit, you have to invest some work in the ontology of process profiles. I think it's more valuable to invest that work, and my argument actually is focused on phenomena like the Wiggers diagram. People are already measuring the values which are realized through the course of such process profiles, just as they're measuring quality. In fact, it's the same thing. Any more questions? All right, so I'll see if I can find the non-medical parts of this. All right, so this is what the differential equation represents: the increase in temperature. So these are examples of quality universals. The determinables are length, weight, temperature, and the determinants are 6 centimeter length, 7 centimeter length, and so on. So we need the same kind of treatment of hierarchies of qualities that we have been giving to hierarchies of processes, because the hierarchy of process profiles, because the process profiles themselves were often generating hierarchies on the basis of distinctions between determinable and determinate quality universals. So this is an example for process profiles. So we have the speed profile of a movement, and one subtype of speed profile is a constant speed profile, and then a subtype of that, it would be a 2 miles per hour constant speed profile. But another subtype of speed profile is a variable speed profile. Now, one way of dealing with variable speed profile, which could be over here, would be to treat the variable speed profile as a constant speed profile followed by a different constant speed profile followed by another different constant speed profile. But we can only do that with stepwise variation in speed, which is very hard to obtain with finite powered engines. And so we need to have at hand the idea of an acceleration profile, which is a special kind of speed profile. And the first subtype would be a constant acceleration profile, which would be one of these, and then variable acceleration profile, and then we'd have increasing acceleration profile, and so on and so on. It goes on and on. Infinitely. Now, one of the reasons I have to confess why the process profile idea has not been introduced into BFO is because I still haven't found a neat way of documenting this. Now, this is the differential calculus. When we've done it all, we've done the differential calculus. And I am not good at documenting the differential calculus in a way which would be comfortable for the usual audience of BFO to accommodate. So I need to find a quick and not very unclean way of documenting the differential calculus. All right, now this is some more sneaky underhand attempts to document the differential calculus. All of this is more attempts. So actually I can read this because you'll see the point. So to say that John is moving with speed v at a certain time t is to say that there is some temporal interval, including t in its interior, in which the constant speed v process profile is instantiated. What that means is, given any epsilon, however small, we can find some interval such that, and so on, differs from v by less than epsilon. So this is, to do this properly is hard work. And we've said that already. This is process predications. Oh yes, this is sort of interesting. So we have been talking about process profiles of one object, like a heart, or of a small number of objects, such as, or a top, or a small number of objects, such as the atrium and the ventricular chamber and so on. But, and then we get process predications like this. So we measure some object, we get the value n for some quality. We measure some process, we get the value n in some measurement unit u for some attribute of the process, for instance speed. What that means is that there is some process profile which is a streamiform part of the process, P, and P0 is an instance of this determinate process profile type with F with magnitude n as measured in unit U. But now, every process is embedded within many larger processes, in the end embedded within the history of the entire universe. And when we are focusing on processes within this massive conglomerate of interconnected process profiles within these larger wholes, we can focus sometimes on the process profile of the one object we're dealing with, but we may focus on relative process profiles. So if a billiard ball is moving across the table, we can focus on the ball's movement relative to the table, or we can focus on the larger process, which is the movement of the body table system relative to the motion of the Earth. Or we can focus on the motion of the body table Earth system relative to the movement of the Sun, for instance. We would never do that, of course, but we could do that. And some people do that. So you're a kidney physiologist, so you're interested in what goes on inside the kidney, or you're interested in interactions between the kidney and other parts of the urogenital system, or you're interested in interactions between the urogenital system, including the kidney physiology, and other bodily systems, or you're interested in interactions between this system in people like him and the location of alcohol, places where you can buy alcohol in his environment, for instance. And so each one of these generates process profiles that become progressively more complicated as you move outwards. So, and now we can do statistics. So a physiologist is interested in processes in a single organism, but he may be interested in processes in this single organism as part of the larger whole, which includes a lot of organisms for all humans. Is this a normal human, typical human, or all human babies of a given birth weight, or all athletes? So when we measure process profiles, we don't always measure just what is going on here. We sometimes measure deviations from a statistical norm relative to a given reference class. And the reference class may be different. And normal processes, when you're dealing with normal processes in medicine, for instance, are always relative to some reference class. And what is healthy for an athlete may be, what is healthy for an alcoholic, sedentary gentleman may be unhealthy for an athlete. And so the processes which we measure when we measure health will be measured differently according to whether we're measuring to determine health relative to this reference class or that reference class. All right, so and then so I'm not going to read all of this, but a physiologist is studying he can study different, or she can study different process profiles, kinetic, hydraulic, electrical, chemical, and so on, within the kidney. But somebody may investigate the photodermatological processes which occur when the epidermis is exposed to sunlight, for instance. So that's a very interesting process profile which involves the skin of the patient, or of the reference class of patients being studied, and the sun. And then processes of exposure, the process involved when the skin of this patient is exposed to sunlight.